Hi everyone, Dan Gunner from Insane Forensics. Welcome back to Tech Talk Tuesday, where every week we try to give you something to help your threat hunting and security program. And today what we're going to dive into is how to write Yara binary rules. Last week we dug into Yara string rules and we looked at what Yara was, we looked at dealing with uncertainty on not knowing what string order is, we talked a little bit about conditionals. So if you need to know any of that, definitely check out the last video. This week, we're going to focus very heavily on binary rules. Hopping right in, what is a binary rule and how does it work? So when you're looking for specific hex values or byte values within the file, that's when you use a binary rule. And you can use these rules next to string rules or as other strings in that rule logic. In this case, we have a string $A that's looking for hex 0x deadbeef. And this is the only value it's looking for. So this is a very simple example of how to do a Yara rule to match that very specific hex value. Now, let's say that there's some uncertainty or there's some characters in between there, right? So now we're looking for either dead DD beef or dead BB beef. What we can do with adding parentheses and then, the characters that it might be either or of, we just added in this syntax, right? So in this case, we still have dead at the front, we still have beef at the back, and now in the middle we have parentheses and we're saying either this is BB or DD. Now we're matching on dead DD beef and dead BB beef. So when you're dealing with uncertainty values, this is as simple as it is on there. Now let's say you don't know what that placeholder value is. So in the last slide we talked about DD or BB being in the middle. You can use what's called the placeholder character, which is just question mark, question mark. And what this is going to do is it's basically going to say, okay, you can match any byte in the middle of these. We don't know what it is and we don't care what it is, right? So it could be dead AA beef, it could be dead ZZ beef, it could be a number. So this is what the placeholder character is. We could also put this in as what's called a jump, right? So if we have dead and then we do square brackets 1 or square brackets and a number and then we do beef, what this is saying, hey, match on dead, jump a space, and then match on beef. So again, we don't care what's in the middle here. This is similar to the last slide when we use two question marks. With this jump character, we can also provide a range. With this, and the range you see here, we give 50 to 100 characters. This is inclusive, so it's going to look dead. It's going to look from 50, starting with that, all the way up to 100 of anything in the middle there. But what this is going to match on is anything where there's dead at first, 50 to 100 characters, and then beef after. They don't have size limits once you get past Yara 2.0 and beyond. I think we're on Yara 4.0 now. When you are using this in other tools, it's important to be mindful what version of Yara are they using in the back. And so again, if you're in Yara 2 or beyond, you can do jumps and there's not a size limit on how far you can jump. And in fact, what we'll look at here is an infinite jump, right? So let's say you're in the first example, right, you're matching on dead, then you're saying jump at least 50 spaces and out to a potential infinite amount and look for beef. So in this case, you're going to match on dead, jump the 50, and then as long as it matches beef, 50 spaces or beyond, you're going to get a match there. You can also do a 0 to infinite match here. So, right, if we're not sure if there's anything even between dead and beef, we might jump 0 to infinite spaces by just giving it that dash character. Why we're going over this is it's important to understand this notation. It's important to understand when you're looking at a rule or when you're maintaining a rule, what is meant by this. And so if you see square brackets and you see that dash, that's basically saying, okay, that's a jump 0 to infinite example. What we can also do is, so we talked a lot about matches that the offset wasn't provided, right? In the case we provided, we said, okay, match on dead, and then match on, 0 or some offset or some number of skips in between. Here, what we're going to look at is actually matching a byte value on a specific offset. And so what you see here is you see in the condition field, we have that uint16, and then in parentheses, you have that 0. This is saying take a 16-bit value and starting at offset 0 and see if it's the value provided there. So 0x5A4D, which is MZ. This is actually the magic file header for an executable, right? For a Windows executable, it's the MZ character. On this, if we know that specific character and we know the specific offset that we're matching at, this is a useful way of doing that. The uint16, this is an unsigned integer. You can also use ints, which are assigned, obviously, so you have options there. You also have the option to use big and little endian order, so depending on how the data is encoded as, if it's network format, if it's host format, you have a lot of options for how these bytes or strings are matched here. So again, this was a very quick overview over Yara binary rules. And what we wanted to do was just walk you through kind of a series of different rules, talk about what they looked at, and really get you in the place to where you could take this knowledge and write your own rules. So hopefully leaving this today, you kind of understand what Yara binary rules look like. You understand a little bit of how they work and some of the notation you can do with them. So thanks for joining in this week, and we hope to see you back next week.